Welcome to this eLearn Security video training lesson on SQL Injection. In this lesson, we're going to learn how to identify a SQL injection flaw and how to exploit it. The first step is to manually explore our target application in order to find a possible injection point. To do this, we will simply navigate through the site and look at the parameters passed by the application. This is our web application. It's a simple website where people can upload and share their selfies. If we hover the mouse on these pictures, we can see that it will take us to another page where there is a parameter called ID, which seems like it is holding the ID of the picture. Let's open one of these links. As we can see, the ID equals 2230 appears at the top. We can try to change this value in order to understand how the web application handles it. For our test, we will type an apostrophe. This should cause an error since the SQL statement has been modified. In this case, it tells us that an invalid SQL has been used, and also that we are dealing with a MySQL database. We want to see if besides breaking the SQL query, we can also make it process our own query. For this, we will use a simple logical operation, 2230 and 1 equals 1, semicolon, space, minus minus, space minus. Since 1 equals 1 is always true, if that works, we should see the same exact content we were seeing. Now, let's try it with the false condition, which should not give us any result. So it looks like we have a SQL injection here. Let's recap what we are doing to better understand why this is happening and why we get different results. Let's open a text editor and write down our inputs. We can suppose that with the following input, the web application is running a query similar to this. Select views _ counter where ID equals 2230 and 1 equals 1, semicolon, minus minus, space minus. Let's inspect it step by step. The first part of the query simply gets the counter view of the ID 2230. This query works and returns true, because the ID exists in the database. Indeed, if we go back into our web application and try it with an ID that probably doesn't exist, such as 9999999, we can see that we do not get any results. Let's go back to our query and continue our investigation. It's obvious that 1 equals 1 is always true, so with the logical operator and between the two, the query still works because the returns are true. Remember that the logical operator works in this way. The result of the AND is true only if both operands are true. In all other cases, the result is always false. The last part of the query simply tells MySQL to ignore everything that will be added right after. This is because we don't want the web application to add other strings to our query. So if we change 1 equals 1 to 1 equals 2, it returns false. So the entire query will return false. That's why we do not get any result on the web application. Now that we know the application is vulnerable to blind SQL injection, let's open a new terminal window and use eWAPT to take advantage of this vulnerability and extract data from the database. Kali Linux already has eWAPT installed by default. We can simply launch it by running the eWAPT command with the -h option to display the help. As we can see, eWAPT offers a lot of options. We're not going to inspect them all. Instead, we will focus on the options that we need to exploit the specific blind SQL injection. Let's start creating our command. First of all, we have to specify our target with the option -u. Note that we have to type the URL with a parameter and a value for the parameter itself. If we scroll down a bit, we can see that we can also specify which parameters to test. Since in our case, we have only one parameter in the URL, we can omit this option. Note that we already know the target database, so we can specify it with the -dmbs option. But we will suppose that we do not know it and let the eWAPT identify it for us. In the detection section, we can set the level of tests to perform. The higher the value, the more intensive will be the test. With the Techniques option, we can instruct SQLmap which type of SQL injection to test. For example, we can set to test for union-based SQL injections, for blind SQL injections, and so on. For now, let's suppose we don't know it. The enumeration section allows us to specify what information we want to retrieve from the database. For example, the DB banner, the tables, the users, or all of the data. Note at the end of the help output, we also have a parameter named wizard, which will help beginner users to configure SQLmap. So now let's type our command, which is very simple since we just have to specify the target URL with the -u parameter. So SQLmap starts its tests in order to detect if the parameter is injectable. Right after, it tries to detect which database the web application is using. And at the end of the output, we can see that the parameter ID is vulnerable. Since we don't want to test any other parameter, let's continue by pressing Enter. So SQLmap is able to exploit the SQL injection. Indeed here, we can see some information about the payload used, while a bit after, we can see some information about the remote machine OS, the application technology, and the DBMS. So let's try to retrieve some information from the SQL injection. The first thing we want to get is the database banner. We can use the command used before and then add the -b option. Here it is. Let's now try to retrieve some more information about the database and its structure. So, for example, let's try to discover the database tables. Here we are. After a few seconds, SQLmap prints out all of the tables for each database. Here we can see the selfie4u database with 2 tables, and some other database, which is, by default, created by MySQL. So what we can do, now that we have these results, is to pick up the table name, and we can get all the columns from the tables contained in the database selfie4u. So let's edit the previous command by specifying the current database -current -db space selfie4u to use, and then the -column switch to get all the columns. Here we are. We can see for each table which is the columns and their type. Since these 2 tables are very interesting, let's instruct SQLmap to retrieve all the data contained in them by using the switch -dump. Here, SQLmap finds some password hashes and asks us if we want to store them in order to use other tools for cracking purposes. Let's ignore this by pressing Enter and then ignore the dictionary attack too. So here we are. We have the content of each row contained in the tables. We can see the username and the password, while here we can see the data of each picture stored in the web application. So as we can see, once we identify a possible SQL injection, we can easily retrieve the data from the database by specifying a few parameters in SQLmap. And this concludes our video training lesson on SQL injection. Thank you very much for joining us.